Hey folks, welcome to this episode on percent composition of hydrates. Alrighty, now we are going to do an example here that is not a typical example. A typical example will say, hey, we have this hydrate. So remember, a hydrate has waters that are attached to an ionic solid. So in this particular case, our hydrate is copper 2 sulfate pentahydrate. If you're interested in how to name those, I have a video on how to name hydrates. And in those questions, they're usually saying, hey, we have this hydrate, copper 2 sulfate 5H2O. Please calculate the percentage of water or calculate the percentage of our ionic compound. What this question poses is slightly different. So it says that when we have a 1.000 gram sample of this copper 2 sulfate pentahydrate, it was heated so that the waters of hydration, so aka the water that's attached to this, were driven off. But it wasn't heated so hard that it started to decompose the copper 2 sulfate. Now, after this heating, the mass of the anhydrous salt, so remember the anhydrous salt is just going to be this compound right here. So it's the salt without the water attached to it, is found to be 0.639 grams. What is the experimental value of the percent water of hydration? All right, so let's just take a moment and let's see what's actually happening here. So we have this copper 2 sulfate, CuSO4.5H2O, solid, and it is being heated. So we're going to add that little triangle to represent heating. It's going to be heating, and it's essentially going to break this up into our solid and into our waters. In this case, we have 5H2O. Now might put gas here or you might put liquid. I'm just going to put gas here because immediately it's going to turn into a gas, but at room temperature, it's going to come back down to a liquid. So either are technically correct, depends on what you're doing and at what level. So here we have 1.000 grams of this original hydrate, and it was heated. And then after heating, but before it started to decompose, the anhydrous salt, so the thing that was left over, the ionic salt that was left over, had a mass of 0.639 grams. And we're asked to find the percent composition or the percent water that is left over that was driven off. This thing right here. So how much water was actually driven off? Well, this is a very simple calculation. We know that based on our law of conservation of mass, that mass cannot be created nor destroyed. It's only it's conserved, right? We know that if we start off with 1 gram of sample, our products should also be a total of 1 gram. So what's the difference? So we're going to have 1.00 gram minus 0.639 gram, which is what the copper 2 sulfate was left with. And this will give us the amount of water that was driven off, 0.361 grams of H2O that was driven off. All right. Now, this is actually pretty easy because we know that our original value was 1.00 gram. So if this much water was driven off, that's how much water was originally in our 1 gram sample. Right? Law of conservation of mass, that means that mass cannot be created or destroyed. So if we had this much water driven off, that's how much water we originally had in our sample. And so what we can do is a very simple calculation. We can say, well, if we know that 0.361 grams of H2O was driven off, that must mean that our original sample of 1 grams had it. So what is our ratio between water and our total mass of our sample? And so our mass of water that is driven off versus our entire mass of our original sample of our hydrate, right? So H2O is this, and this is going to be CuSO4.5H2O, okay? We can look at that ratio. Now, in this particular case, our grams will cancel out, and we will be left with a ratio of 0.361, okay? That's our decimal. Now, if we want to turn this into a percentage, we can multiply by 100, and this will be 36.1%. And that's our answer. So 36.1% of our original sample was going to be made up of water. So we used a couple of different laws here to solve this, and it's always good to create a visual. This was our visual that we created to kind of put all these numbers into play. We found out that the amount of water that was driven off was 0.361 grams, and if law of conservation of mass is to be conserved, That's how much our original sample had. And so if we take that divided by our original sample, we get a value, a ratio. It just so happened that it was the same number as this because our original sample was 1 gram. But we could do this with any mass. If we had our original mass was, like this original mass here was 39.45 grams, we could do the same process and get to a percentage, or a decimal at least, that we can turn into a percentage. Okay? Thanks very much for watching. I hope you found this helpful. Please like and subscribe, and please watch one of the suggested videos that will help you better understand empirical molecular formulas, either just regular ones or hydrates as well. Thanks again for watching, and see you on the next one.